Good day, folks. Welcome to Price Mind Academy, where we bring freedom to every lesson. In today's video, we're going to be focusing on more practical question and electric circuits. All right, now let's just dive into it. It says now a learner investigates Ohm's law. Now, Ohm's law, remember what does Ohm's law says? It says now the potential difference across a conductor is directly proportional to the current in the conductor at constant what? At constant temperature, the off, right? Now, if the temperature is not constant, therefore it means we have a problem. All right. Now let's answer the questions. Or rather, let's see this. So we have a setup. We have a voltage source. We have a resistor in here. Right. We have an ammeter. Then we have a cell. All right. Now, the learner obtains the following results. Okay. If the potential difference is this, therefore the current is that. The voltage is this, the current is that. Going. All right. Now, let's see the relationship actually. If the voltage, what happens to the voltage, it decreases, right? And also what happens to the current, it decreases, right? And remember, what does Ohm's law say? It says now the potential difference is directly proportional to the current. So if this goes down and also this one goes down, it means now we are having a what? An ohmic conductor off, because now it obeys what? Ohm's law's rules. All right. Now it means we have more or less something like this. Okay. Now, all right, let's answer 4.1. Represent Ohm's law in symbol. You can say R is equal to V divided by I, or preferably you'll say V directly proportional to I. Okay, yeah. Between the two, you can choose this one or this one. All right. Now, let's see the next question, 4.2. It says now 4.2. Calculate the resistance of the resistor in the above circuit. Now the resistance of the resistor, which resistor we have here? This one here, right? This is the resistor that they are talking about. Now we have a potential difference in the current. So it's either you use this value as your V and this value as your current, or this one or this one. But whichever value that you choose, it should match, right? So I'm gonna say R, it is equal to V divided by I. So now, what is V? V, I'm going to choose 12 divided by what is my current? 2.4. Then it gives me how much? 5 ohms. So this, it can work out also if you use this value 9 and 1,8. It will give you the same answer, all right? Yes. Now, let's add this information here. We say this is 5 ohms, right? All right, then this voltage varies, so we cannot include any voltage here, because now we cannot say it is 12. What if they used the 6 volts one? All right, so for this one we cannot just conclude which value it is here, similarly to the current. So then now let's see here 4.3. What does it say to us? Now 4.3 says is the resistor in the above circuit ohmic or non-ohmic resistor? Now give a reason for your answer. We're gonna say now this resistor here, remember also what is the quantity here? Remember actually what is the slope? What is the slope of this graph? The slope here, it is what? It is V divided by I, which is what? Which is R, right? So now the question says to us, is the resistor in the above circuit an ohmic or non-ohmic conductor? So we have to say now it is a what? It is an ohmic conductor. Why are we saying that? It is because now it is what? It is obeying Ohm's laws. So So you're gonna say 4.3. You're gonna say it is ohmic, right? Then you have to give a reason for your answer. You're gonna say, maybe you can say the current is directly proportional to what? Proportional to the potential difference. This is your reasoning. Or you can just say current is directly proportional to potential difference, or you can just swap them around, all right? Or now you can say the ratio of V to I remains the same. The ratio of V divided by I remains the same. If you use the 9 as well as 2,4, if you 12 and 2,4, if you use 9 and 1,8, if you use 6 and 1,2, I think. Yes, it gives you the same ratio. So the ratio is what is constant. It gives you 5. All right, but the easier one you can say now it is ohmic. It is an ohmic conductor because now the current is directly proportional to the voltage. Now 4.4. 4.4 they say to us, where is it? On the same set of axes, sketch the graph of the potential difference versus the current for an ohmic and non-ohmic resistor. Clearly label the graph for the ohmic resistor as P and the graph for the non-ohmic resistor as Q. Now, a non-ohmic conductor, what happens to it is that as time goes on, when the voltage becomes so high, it causes what? It causes actually when the resistance becomes so high, the voltage becomes so high, it increases the current, right? Because now the voltage is directly proportional to current. Actually, what I'm trying to explain, for a non-ohmic, when the voltage becomes so high, it causes an increase. It results in increase in the current, right? Then, if the current increases, can you? I want you to do this practically because this is a more practical question. As the current flows too much, when the voltage is high and the current is high, can you agree with me when you hold your charger? Let's talk of a charger. Can you agree with me that your charger becomes hot now because why? Because there is an increase in the temperature of the resistor. All right. All right. If the voltage increases, it causes the current to increase, therefore causing the temperature of the resistor to increase also. Now when the temperature increases, then what happens? The resistance increases. Remember we said it causes the temperature of the resistor to increase. Therefore, if it increases, the temperature increases, it causes the resistance, right, to also increase. Therefore, all right, I think there is a question where we have to explain that. Yeah, we'll just do it. Now let's just draw for an ohmic conductor. Remember, for an ohmic conductor, it will be just a straight line, all right? A straight line. Then for a non-ohmic conductor, as time goes on, it does this, basically. So it starts off trying to be an ohmic one, but as time goes on and temperature increases, now causing the increase in the resistance. Now it will cause the current at some point not to flow because it will be too hot for the current to flow. Therefore, the current will do what? Will be limited there. Will be limited into increasing, therefore causing it to burst maybe. Now let's say this is V, potential difference. All right, measured in volts. Then this is current measured in amps. Okay. Now I think we were supposed to label this as P and Q. So the ohmic is going to be P and non-ohmic is going to be Q. All right. This was easy 2 marks Just understanding the concept. Now, 4.5, explain fully why the curve of a non-ohmic resistor differs from that of the ohmic resistor. Now, here's your reasoning. Remember, I said what happens. 4.5. I said what? An increase in voltage. An increase in the voltage results in an increase in the current. In an increase in the current. Now, if there is an increase in the current, it causes what? Which causes the temperature. The temperature of the resistor. The temperature of the resistor to increase. Now, practical illustration. You are having your circuit there. Here it is. Alright. Now, your voltage becomes so high now. Remember, there is only one resistor. If your voltage increases now, it causes the current here, the current to do what? To also increase, right? Now, an increase in this current is going to cause an increase in the flow of charge within this resistor, right? So this resistor is going to have more charges flowing into it. Né? So if that happens now, it's going to do what? And there will be an increase in the temperature. It will start feeling heat. This resistor will start to feel heat. That is unusual because now there is an increase in the amount of charges that it gets, right? So if the temperature therefore of the resistor increase, or rather, we started by saying now an increase in the voltage results in an increase in the current, right? Therefore, which causes the temperature of the resistor to increase, right? Then the next point that I can say is that when the temperature increases, when the temperature of that resistor increases, what happens? What happens now? The resistance, the measure of a resistor, the resistance increases. Therefore, if that happens, therefore, what will happen now? We'll say when the resistance increase, the current here, the current will be limited. Current will be limited. All right. Therefore, the ratio of the voltage and the current will no longer be the same now. Right. So the important part is that an increase in the voltage results in an increase in the current, which causes the temperature of the resistor to increase. Right. Therefore, it causes the resistance to increase. All right. Therefore, after the resistance increases, now the current becomes limited now. All right. Yes. All right. 4.6. 4.6. Give an example of a non-ohmic resistor used in our daily lives. Now, non-ohmic resistor, you can say, I think 4.6. Bulb, light bulb. Light bulb is an example of a non-ohmic resistor because now what happens when you light up your bulb, what happens to the temperature of it? It increases, right? Increasing the resistance of it, right? Yes. Light bulb there, not just bulb, light bulb. All right. Now 4.7. 4.7 says now to us, remember now we calculated this resistor here, all right? We calculated this resistor as 5 ohms. Which means this is not the question, this one, right? As 5 ohms. From which question? From this question here. We calculated this R as how much? As 5. Now there is a new scenario now. They say now the learner now adds 15 ohmic resistor to the circuit. As shown in the here is that 15 ohmic resistor that was added, right? So this one they haven't told us anything about it. Just ignore it for now. Okay, just ignore this. All right, calculate the total resistance of the circuit. Now the total resistance of the circuit, you all agree with me that our total will be what? The 5 ohm that we calculated plus what? Plus the 15 ohms that was added. 20 ohms. All right, 20 ohms there. RT is gonna be what? 5 plus 15, which is equal to what? 20 ohms. Now, 4.8 now they say to us, how will the ammeter reading compare to the reading given in the table if the learner uses 6 volt cell? Write down equal to, greater than, or smaller than. I repeat, how will the ammeter reading compare to the reading in the table if the learner uses 6 volts? Now, let's say now, okay, if how will the ammeter reading compare to the reading given in the above table if the learner uses 6 volts? Now I want you to see something. If you use this part, this 6 ohm, here, if you use this 6 volts here, all right, to compare, if you, instead of using this V, we use now this 6 volts here, how will it affect the current thereof? All right, how will it affect the what? The current. Now the current will do what? Will decrease, because now can you check that the starting value that you started with was 12 ohms, right? So also now there is an influence of new other resistance. So now if we have 2 resistors that are connected in series, they increase the total resistance, right? Therefore, you know, if the total resistance increases, what happens to the current? The current will decrease. Alright? Yes. Similarly, the 6 volt that is used thereof, it is small, right? So it will cause the current to be smaller than. The answer is smaller than there. Answer is smaller than. Right. 4.9. Let me try to adjust to this so that you can see. Yes. 4.9, where is it? It says now to us, calculate the potential difference across the 15 ohm resistor if the 6 volt cell is used. This we are not using. We are using what? These 6 volts here. Now they say what? Calculate here the potential difference. Calculate the V here. The V of 15 ohms. Actually, that's what they're asking us. Now we already have the resistor, right? Now what we can do is to find the current, because now the current will be the same throughout. You all agree with me? Now let's find the current. Remember, this is now our V total. Okay. Then our R total is this one, so we can find the I total, which is the same, remember, in series. All right. So now I can say, how do I calculate I total? I'm gonna say I is equal to V divided by R. But remember, it should be all the totals, right? Therefore, what is my V total? My V total, it is now 20 divided by, what is my, my V total, it is 6. What is my R total? My R total, it is 20. Therefore, when you do this mathematically, we get a value of 0.3 amps, right? Now, after getting that 0.3 amps, what do we want? What do you want? You want the voltage. Yeah, let's come here. We want the voltage of the 15 ohm resistor. But we know V it is equal to what? IR. Alright? Now what is the current? The current will be the same as the current total multiplied by the resistor which is 15. So we get the value of 4,5 watt. Okay, so this is how you are supposed to go about that one. 4.10. Let's see if we have 4.10. Yes. Now before 4.10, there is a scenario that says to us, a learner now adds a third resistor with a resistance of 10 ohms in the circuit and replaces the cells with different cells. Now, yes, the cells should be different, but it is still the same 6-volt cells. Or let's not do that assumption, but yes, you should replace your cells because now they already have the value. If remember, as you use your circuit, the voltage decreases. Remember, if you buy a 6-volt battery, as time goes on, if you use it, you get it is now 5.8 volts. So it's going to affect your results. All right? Yes. So remember now, can we see that the resistor that was added in parallel, right? And remember, I said when you add a resistor in parallel, add a parallel resistor, you decrease the R total. You decrease the R total. Remember, the R total was 20 ohms, right? So yes, you decrease. You will just see by how much in case we are asked to calculate that. Now they say calculate the total resistance of the above circuit. Yeah, now we will see. Now you all agree with me that this is in series, but when it reaches this point, it branches out in here. So we have to calculate RP first, then we add that to our R series. All right. Now, how do we calculate RP if we have two resistors? RP if we have two resistors. Remember, RT will be what? RS plus RP. All right. Now, how do I calculate RP? RP, remember, if I have two resistors, R1, R2 divided by R1 plus R2. Therefore, what is my R1? 15 times 10 divided by 15 plus 10, which is 150 divided by 45, which is, I think 6 ohms. Yes, 6 ohms there. This is my R parallel. Now, and I know that my R series, it is equal to 5 ohms, right? Yes. So I now substitute into my formula and say now, therefore, R total, it is equal to what? 6 plus 5. So it is going to be 11 ohms. Can you now see this value is less than this value thereof? Is less than this value here. 11 is less than 20. So I wanted to do this practical question so that you understand that all the things that I've been explaining about Ohm's laws are not false. I wasn't adding them up, right? Yes. Yes. It is very important that we also do an experiment question. Now the last question says now how will the voltmeter reading how will the voltmeter reading of a voltmeter connected across 15 ohm resistor compared to that of the voltmeter connected across 10 ohm? All right. Now they are saying how will the V here compare? All right. Simple English is running away. Compare the voltage between these two branches. Actually, that's what the question is asking us. Compare the voltage between these two branches. But we know that if branches are connected in parallel, actually, if resistors are connected in parallel, what happens to their voltage? We said what the voltage is the same. We said the voltage is the same. If here we have 10 volts, it means here we have 10 volts. All right. So now the correct answer there is what? It will be the same, equal to. This is your answer. This is how the voltmeter reading across the 15 ohm compared to that of the 10 ohm. So yes, that's all for the practical question. I hope you enjoyed and understood the concept under Ohm's laws and how to apply it. Thank you very much.